All right, so for number 1, this is on the no calculator section. In this textbook, remember, standard form is vertex form, so that you can see the vertex. Okay, so guess what? They give it to you in this form, so if it's already in what normally you think of as standard form, you're going to have to write it so that you can use completing the square. Okay? Now, if your first value is not A, you factor that out, and then you complete the square. So half of 4 is 2, 2 squared is 4, but really, anything in the parentheses is multiplied by 2. So we didn't just add 4, we really added 8. So to balance the equation, you're going to have to subtract 8. Okay, so f of x equals 2 times x plus 2 squared plus 1. This is a minimum value, and then function notation is your f of h equals k. Okay, so if your vertex is negative 2, 1, it's f of negative 2 equals 1. Questions on that? Just this part? The beginning of it is the completing the square, so you're always going to group the first two together, and then if this is not 1, you're going to factor it out. So when you factor it out, you get x squared plus 4x. And then you're going to do not negative b over 2a, but b over 2 squared. The negative b over 2a is when you're finding the vertex of a parabola. When you're completing the square, you do half of b squared. So half of 4 would be 2, 2 squared would be 4, and then you have to multiply it by the 2. And then whatever you do here, you do the opposite. So if you add 8, you're going to subtract 8. And then it's a minimum because your a value is positive. So if it's positive, it opens up, and that means you have a min. Okay. All right, now you're going to have your calculator for number 2. That doesn't mean that you have to find it on your calculator. I actually like doing it with algebra because it's quicker for me than plugging it into my calculator. Do a lot of you do that with algebra? This is where you do opposite of b over 2a. I do think this is quicker, and this test is comprehensive, so we should try to do the quickest method. So opposite of b over 2a. Okay, this is the input or the time. When they're asking you for the maximum, you're going to take that x value, plug it back in, and that's going to be your answer for A. The maximum height is 64 feet, and then the time it occurs is 2 seconds. You know that because t is your input here. H of t is the height. You could also graph this on your graphing calculator and use your maximum function. And when you do that, your maximum function is 264. Just understand that this is your t and this is your h of t. Okay, that's what your point is. Did number 2 go well? When you say sure, that makes me think it did not go well. Okay, so again, the formula for doing that is the opposite of b over 2a. Anytime you're finding the maximum, what you're finding is the vertex. So to find the x-coordinate of the vertex, opposite of b over 2a, okay, plug it into the original function to find the y value, and the y value is your maximum. Okay, so 64 is the maximum height. Okay, and then number 3. So number 3 is not on your calculator, so you're going to be using the leading coefficient and the degree. Okay, and then when you're writing this out, y goes to negative infinity as x goes to negative infinity. Y goes to negative infinity as x goes to positive infinity. The order of those two, like if you did the positive infinity first, that would be fine. It's just if there's an even degree, it's the same. They're going in the same direction. And if it's a negative coefficient, it falls on the right. So if it's an odd degree, they would go in opposite directions. And then if it's a positive leading coefficient, it would rise on the right. Did some of you write this with the x first? Yes. Is that what you're saying? Yeah, that's fine too. So if you wrote as x goes to negative infinity, y goes to negative infinity, or did you guys put f of x? Okay. This is f of x, but either way you write it is going to be fine, okay? Yeah, if you write it like this, that's fine too. That's how we learned it last year. Different textbooks do different things, but it's the same thing. Yeah, I just try to follow what you'll see. Yeah, it means the same thing. It's okay. All right, and then we're going to divide using long division next. Okay, you guys have been doing a good job at long division, so let's check this, and then if we need to do it out, we can. Okay, so when you're doing long division, just be careful if there are like missing ones here. Like, look, see how this was negative 4x squared? This was negative 2x cubed. Okay, so you have to put it in standard form first. And then once you put it in standard form, you ask yourself, okay, what times x squared would give you x to the 4th? Yeah? So x squared times x squared is x to the 4th. X squared times negative 4, negative 4x squared. Then you switch the signs. This is going to drop down. This actually cancels out. This will drop down. Okay, and then what can you multiply by x squared to get negative 2x cubed? Negative 2x. Multiply, you get negative 2x cubed plus 8x, so then you change to a plus and a minus. And then how do I know to stop here? Yep. Degree is less than divisor. Okay, so then when you're writing this in alternate form just means you do the quotient plus the remainder over the divisor. And if this is positive, it's a plus. If that is negative, it's a minus. Yeah. Questions for me? Okay. Questions on long division, though? Okay. Then, for this one, it says to solve by factoring. So if you're solving by factoring, you don't need your calculator. If there are 4 terms, you're going to group them together. Okay, so then you're going to take out the GCF. So this would be x squared, x minus 3. Take out the negative 4, because when you're doing this by grouping, these have to match. Now, we had this, something kind of similar on our quiz. Remember, when you're solving by factoring, make sure you factor this. So you have to write this in factored form. Okay, so you have x plus 2, x minus 2, x minus 3, and then equals p of x. So will you put equals p of x for me, please? So that is this in factored form. Then all you have to do is find the zeros. To find the zeros, you set them all equal to 0. X plus 2 equals 0, x minus 2 equals 0, x minus 3 equals 0. So your zeros are negative 2, 2, and 3. Does it check out that you should have 3 zeros? Yes. Do you guys think that's one of the simpler ones? Okay. I do too. What's that? Okay. All right, and then for this one, when you are evaluating the I to the 45, remember this is where you have to write it in terms of I squared. So if it's an odd number, then it's only going to go in there enough times to make it even, and then you multiply by I. So 2 goes into 45 22 times without going over. Because what's 2 times 22? 44. And then this is your power of exponents. When you are multiplying exponents, if you have I to the 44th times I, it's I to the 1st, right? What do you do with the exponents? Add them. That's how, we're just rewriting this, okay, to simplify. So you have negative 1 to the 22nd times I. Negative 1 to a power is either going to be negative 1 or positive 1. What's this one going to be? How do you know? Yep. Even exponent, it'll be positive. Odd exponent, it'll be negative. Okay? Exactly. Yep, so it's 1i or just I. Either one is fine. Okay? Whichever one you want. Okay. For 16, you should have, or B, you should have 2 plus 2i. How did that go?
Oh, I did get that.
Okay. So you have to multiply by the conjugate of the denominator. So you want it to be the opposite here, so that when you FOIL, 4 times 4 is 16. If they're opposites, what's going to happen to the i's? They're going to cancel. Negative 16 and positive 16. A negative times a positive is always negative, so this should be negative 16i squared. You're going to plug in negative 1, which means you're going to be adding these together, so the denominator becomes 32. Okay, and then the numerator would be 64 plus 64i. And then remember, you are writing this in the form a plus bi, so you have to reduce. Okay, and then they actually reduce to whole numbers for this. Okay, so that's your final answer. Mm-hmm.
Would it be fine to, before part by the 6 divided by the 3 by 4, because 4 doesn't sit on the side of that?
It's just not an equation, so you could show that you factored out the 4 in front and then simplify. Yeah, you could do that. Yep. Just make sure that you show that part, okay? All right, and then for C, quiet, please. For C, you have to make sure that you simplify the negatives first. You cannot multiply 2 negatives and say that they're positive. You can also simplify root 12, right? So if you have I root 12, what's the perfect square in 12? 4, so it's 2I root 3. Okay, so you're going to simplify that. Then we are going to FOIL. When you FOIL, first times first, 2 times 21 is 42. And then I like to do the inside first. So I do 21I root 3. Then the outside plus 4I root 3. And then negative I root 3 times 2I root 3 is negative 2I squared times, what's root 3 times root 3? 3. Notice that I write it down, like I give myself a chance to process that, because there was a lot going on in that multiplication. So then I'm going to plug in the negative 1. Okay, so I have negative 2 times negative 1, which is 2, and then 2 times 3 is going to be 6. Okay, and then here, you can combine the negative 21I root 3 and the 4I root 3. Negative 21 plus 4 is negative 17I root 3. And then 42 plus 6 is 48. Okay, so this is going to be your final answer. Okay, for number 7, when it says find all solutions of the equation and write in this form, you are not going to be able to factor if they are imaginary. If you have imaginary solutions, you can either solve using the quadratic formula or completing the square. Okay, so the quadratic formula or completing the square. That's up to you. I use the quadratic formula, and when I simplified, I got 3/4 plus or minus root 79 over 4. Okay, this is another one where, do you notice how you could divide everything by the GCF? What goes into all of those? 2. You could divide everything by 2, then do the quadratic formula. And then you do have to, if you do it like this, you will have to find the biggest perfect square, which is 4. And then a negative will be I. Okay, if they ask you that in the directions, you're going to have an I with it. And you can either put the I on the side or you can put it in front of the square root. Okay? And then for number 8, find a polynomial of degree 3 with the integer coefficients. You should have p of x equals x to the third minus 7x squared plus 41x minus 87. Okay, so for this one, anytime it's a binomial, you're going to have these brackets that you need to set up. So the factors are always x minus c. So x minus 2 minus 5i, and if 2 minus 5i is a 0, remember, 2 plus 5i is also a 0. So you have x minus 2 plus 5i. Once you distribute that negative, distribute the negative, you are going to regroup. Have you noticed that every time you regroup, these two are the same and these two are opposites? Guys, pay attention or be quiet so other people can. Okay, and then once you FOIL x squared and x squared, you get x squared minus 4x plus 4. I'll tell you the part that people usually forget on this test. They forget to combine this at the right time. So you have to make sure all of these are in brackets. When you FOIL these two together, you have to make sure that you add this first and not at the end. So you should have x minus 3, x squared minus 4x plus 29. Then you distribute. Distributing will be your last step, not this addition. Okay, for 9, I said you didn't have to state the multiplicity if there is one. For A, the only real root that you have is negative 3 over 2. Okay, so negative 1.5. So that's why I went back and I wrote out all of the P over Q's, so I would know what my x-intercept is when I saw it. Okay, so if it's not a whole number, then you go back and write the P over Q's. If it is a whole number, you're good. You can just find the x-intercept. This is another one where you have a quadratic where if you wanted, you could divide everything by what? 2. That makes the simplifying a little bit easier if you notice that. Okay, and then it says your zeros is negative 3 over 2, and then negative 1 plus or minus, I root 3. And the total number of zeros is 3 because it is the same as the what? Degree. I just said it's a fundamental theorem of algebra. You don't have to say that. You can say the total number of zeros is 3 because it is the degree. Do not say it's the exponent. You have multiple exponents. Okay? It's the degree. Okay? All right. And then for B, you have this. Your zeros are 1. It is a multiplicity of 3, but I said you didn't have to state that, okay? You do need to know it, though, because if you don't, are you able to get the quadratic? No. So you know it's a multiplicity because it bends through the x-axis, okay? And really, if that's the only thing you have on your x-intercepts, that should be a big hint that you have a multiplicity, okay? Did that go all right? Okay. All right, let's go to the next one.